Mechanics. Two meteorites. One meteorite with mass small m was moving towards another distant meteorite with mass big M. Flying near it, the meteorite lost part k of its velocity in the frame of reference relative to which the second meteorite was initially at rest. In this case, the first meteorite deviated from the initial direction of motion by angle beta. What is the mass ratio of the meteorites? M big over M small. So to solve this problem, we can use both energy conservation and momentum conservation here. And because initially the distance was very big, and finally distance was very big, so potential energy is zero in both cases, and we can neglect it. So first we can use kinetic energy conservation and write this equation. Here we have on the left v, it's initial velocity of the first meteorite. On the right we have v1, it's a final velocity for the first meteorite, and u, it's a velocity of the second meteorite after interaction. And when we know that first meteorite lost part k of its velocity, we can rewrite this equation in form of represented here. After some subtractions, like this one and this one, we can write this relation. So we have from energy conservation, we have big M u square equal k multiplied by 2 minus k multiplied by small m v square. This is the first one. So we don't need this anymore. So next step is to use momentum conservation. For that, it's better to draw the picture. On this picture, we have initial velocity of the first meteorite v. After that, it deviates for angle beta and moves with the velocity v1 in a different direction. Of course, second meteorite in this frame of reference, initially it was in rest, and after interaction it starts to move somewhere, and we can count what is this motion. For that we have to redraw this picture. Now from this picture we can see what happened to momentum of the first meteorite. Initially it was mv, and after that it was mv1. So the total difference is this one, which is exactly equal to opposite momentum of the second meteorite, because they just change each other. And this momentum we can count from cosine theorem using this triangle. That will be this expression. Now, after several manipulations, we can rewrite this formula in this form. But as we mentioned, this momentum change, that's exactly equal change of momentum for the second meteorite, like this. And after all, we can rewrite it in this form. Now we have two relations. First relation came from energy conservation, and the second came from momentum conservation. And the last step to do is just to divide the second relation for the first relation. Finally, we will get mass ratio. This is the answer for the question. Big M over small m equal this expression.